Hi everybody! Are you interested in transforming your ordinary 3D models into the enigmatic cloaked figures seen in sci-fi games? Achieving this captivating effect is remarkably simple. You'll only require 2 lines of a shader code. Discover the process by watching this video. So, I'll demonstrate the effect on a scene from one of the games I'm currently working on. As you can see, the project is currently in a notably incomplete state. It serves more as a proof of concept. My intention was to assess the compatibility of a third-person controller with a Mixamo model. If you're not familiar with Mixamo, it's a website developed by Adobe that offers a great selection of pre-rigged characters and animations available for free, which you can easily export and incorporate into your game projects. Okay, so this is the character we will use to show the effect on. What we need to do now is to create a new shader material and build a spatial shader that would be assigned to it. Let's do it. So I will right click on the folder shaders and create a new material first as a resource, and we want to use shader material. Okay, let's call it cloaked and save. And now of course we need the shader itself to assign to it. Right click again, create a new resource, and we create shader. And let's call it cloaked again. Okay, and double click to open the material and drag the shader here. Okay, double click and we open the code. In this simple shader, we don't even need to set the basic albedo color because we will work only with the alpha channel and the emission. Why the emission? Well, since the result may appear rather dim, we want it to shine a little bit, so the player wouldn't have problems recognizing where the character is located on the screen. And of course, we will expose these parameters as uniforms, so we will be able to modify them in the inspector later. Let's add 3 uniforms we would like to work with. So first, uniform vector 4 emission color, which would be type source color. Now we need emission amount to define how powerful the emission would be. Uniform, that would be float emission amount. And let's give it a hint so we can easily select from a predefined range. Hint range would be not this, but 0 and 16. Okay, and default value, let's set it to 5, for instance. The hint range is from 0 to 16 because this is Godot's range for the emission multiplier. And finally, we need a uniform float. We call it rim sharpness. I'll explain it in a while. Just let me finish the definition. And again, from 0 to 16. And the default value we will set to 3. Okay. So, what is the rim sharpness? Occasionally, it can be quite appealing to emphasize the visual outlines of the model, enhancing the character's visibility by highlighting its contours or refining the model's appearance in alignment with other parameters. Okay, so the uniforms are set. Let's proceed with the most important detail of the shader code, which is the dot product. What is a dot product? Also known as the scalar product, It's a mathematical operation used in linear algebra to combine two vectors and produce a single scalar, a single number, as a result. The formula to calculate it is the following. I will just write it here. So let's say we have vectors A and B. So the dot product, I will use this kind of dot, is the length of the vector A multiplied by the length of the vector B multiplied by cosine of theta, where theta is usually the angle between the vectors A and B. Fine, but why do we use it here? We will calculate the dot product of view, which is a built-in variable in the fragment function, and it's equal to the vector from the pixel to the camera, and normal, another built-in variable. This time it's a normal vector. It's perpendicular to the particular face of the mesh. The result will tell us how much the fragment is, let's say, looking away from us, the observer. If it gives 1, it means looking straight at us. 0 would be looking sideways, and -1 means it's looking away from us. This is the fundamental feature of the shader, as we will set the depth perception of the final effect. So let's convert it to the code that is understandable by the shader. Alpha equals dot product, normal, and view. Okay. But a dot product is just a beginning. If we want to make the model transparent in the middle and shining on the edges, we need to subtract the result from 1 and exponentiate it to the power of the rim sharpness. Let's do it. So it would be 1.0 minus this, and now you'll use power, and the exponent is our rim sharpness. Okay, let's try it on the model already. So Ctrl S to save. We will select all meshes of this model, surface material override, and drag our material there. Okay, just please ignore the skeleton. It surely won't be displayed in the game. And let's try it out. Execute. Okay, something is definitely there, and it looks transparent. It looks shining a little bit, but not much, so there's still a lot of work to do. We are almost there, but something is still missing. We should add the emission color to the formula, or more precisely, its alpha value. So let's open the shader again, and we will multiply this line with the emission color alpha value. All right. By the way, once we write to alpha, the material will go to the transparent pipeline. It can mean a decreased performance on the scene rendering, but unless you want to use hundreds of transparent objects simultaneously, maybe thousands, you shouldn't spot the difference. Okay, let's execute the project again, and we can see, yeah, it might be slightly different, but the character still isn't too visible because first, background is too light to illuminate it, and second, we didn't set the emission in our shader yet. Let's get back to the code and start with darkening the environment. So I'll switch to the main scene, find the direction light 3D, and change the color energy. I will use the least possible value of the light energy, which is 0.001. Okay, that's better. Let's start the game again, and we should see some changes. Yeah, we can. Yeah, of course. It's even less visible than before. but so I would say it looks like a ghost, like when you die in the game and your ghost must run to the body to resurrect. So we'll finally include the emission. Let's open the shader and add emission, which is another built-in variable in fragment. Emission is emission color, and since emission is a vector 3 type and the color is vector 4, we must reduce it to RGB component multiplied by emission amount. Okay, very well. And what happened there? Let's open the sorry, let's open the material, and we can see that the emission color is still black because we didn't set it so far. Let's use some nice color, for example, this kind of blue. That would look cool. Let's start the game. Start the game. Okay, I would say that's definitely an improvement. So I guess we finished the effect. Well, almost. I guess we can improve the render mode as well. Currently we are using default values, which isn't always the best choice. For instance, the default blend mode is blend mix, but we can change it to blend add for additive blending. Let's give it a try. We do it here, render mode, blend add. What happens? Yeah, it seems to be a little lighter. Yeah, I guess the colors of the characters are a little lighter now. It's probably not too apparent on the dark background, but you can experiment with blend modes to find the best looking one for your scene. As for coloring the back faces, I think that the value callback is the default one, so we don't need to do anything in our code. But if you want to be sure, just add it. No, here, just add it to the code. Callback. Yeah, and nothing should change here. One last thing, since we're working with a transparent material, we want to ensure that the depth draw is applied to it. I think the default value is depth draw opaque. I'm not certain about that, so we better add one more flag to the render mode. Depth draw always. Okay. There are of course many ways to tweak it, like changing emission color, emission amount, and rim sharpness in the inspector. For instance, if we change the emission color to green, like this green, and increase the amount of emission and the sharpness to maximum, and start the game, we got another kind of effect that can be used, I guess, as a hologram, for instance. Or if we revert everything back and decrease the amount of emission and the sharpness, so it will become more flat. Let's start it. We get an entirely different material. Maybe that looks more like a hologram, doesn't it? And if we zoom in, at least the eyes are no longer visible through the air. Okay, so that's all I wanted to show today. The great thing about the materials is that you can activate the property Surface Material Override programmatically in the script and add a tween or animator player to the activate the cloak action in the game, which would create a nice looking smooth transition between the states. You can animate the shader materials the same way, so the possibilities to make your game look cool are endless. Okay, thank you very much for watching. Please give me a like if you liked that, and see you in the next video.